Good evening, everyone. Geotechnical Engineering Part A, Soil Mechanics, Chapter 8, Seepage. We are going to review an interesting problem in upward seepage in a sand reservoir. So let's jump to our problem. If we have a quicksand condition inside the sand reservoir below, this is our sand reservoir, this is upstream side, downstream side, and we want to know what is the height of water in upstream side in centimeters if a saturated unit weight of sand inside the reservoir is equal to 2.1 tons per meter cubed and factor of safety against sand liquefaction or quicksand is equal to 1. So in such case, this is our upstream side, this is downstream side, this is sand reservoir, and we these are the dimensions, and gamma saturated for sand inside the reservoir is equal to 2.1. And at the condition of sand liquefaction or quicksand, we want to know what is the height of water in upstream side. The sand reservoir is tilted by 30 degrees from horizon, and that's and definitely we do know there is a upward seepage which leads to a critical condition and finally sand liquefaction. So gamma saturated provided, factor of safety against sand liquefaction is provided, and if you recall this equation, factor of safety is equal to gamma prime over available hydraulic gradient times gamma W, and I hydraulic gradient is nothing but delta H over delta L, and delta H is different from a difference of water height from upstream to downstream, and delta L is the length which water travels within the soil sample. If we magnify the sand reservoir, you can easily see the effect of angle of 30 on our sand reservoir. So if this is 30, which is provided from problem statement from schematic, so delta L, this length which water travels inside the sand, is 30 over sine of 30, which gives us a delta L equal to 60 centimeters. As soon as we have delta L, we can also move to numerator, which is delta H, which is total height minus 60 from if this is our base. So delta H is H minus 60. And if you take a more closer look to the sample, you can easily see if there is an angle of theta by 30 degrees, we have two kind of eye. So this is our real eye, and that eye has two component, IZ and IX, because we are working in kind of vertical direction that or to be more accurate, we are using upside I sub z, which is IZ, and that's I sine of 30 degrees. So if that's the case, replace the equation for I and multiply it by sine of 30 to give you I sub z. As soon as we have this part, we can move to the next part. So our IZ is I sine of 30. So that's H minus 60 over 60 times a sine of 30 is equal to cosine of 60, and that's 1 over 2. So if that's the case, and from problem statement we have unit weight, saturated unit weight of sand inside the reservoir, gamma of water is 1, and factor of safety is provided to be 1. So if you replace that in equation, gamma prime is gamma saturated minus gamma W over I, which is IZ, available I in the area, and that's equal to 1. So if you jot down the numeric value, if you replace the numeric value in, jot down the equation, replace the numeric value on it, and do a little of math, it just gives you height of water in upstream side is a 192 centimeters. That was an interesting problem in upward seepage having the condition of sand liquefaction, and it just gives us a height at the upstream side for this configuration of problem is equal to 192 centimeters, almost to a 20.2 meters or almost 20 centimeters. Thank you. We'll solve more problem in Seepage.